find the volume of a solid between the cylinder and the sphere. X squared plus y squared equal 1, and the sphere x squared plus y squared plus z squared equal 4. Okay, you can draw this thing out. It's not that bad now. Okay, so you have a well, here's the cylinder x squared plus y squared equal 1, right? Sphere, I'm gonna lie on here. X squared plus y squared plus z squared equal 4. Don't know if GeoGebra can sketch this type of cylinder now, but let's see. Yeah, it does sketch a cylinder here. Yep, everybody can see, right? Yeah. I don't know why they have a two color to be the same. Change it to a different color. Yeah, look at this one here. Let's see. The cylinder and the sphere gonna cover the top half of the sphere gonna cover the cylinder. So that is why you see I drew this thing. Cylinder sphere. It look like this. If you project it onto the x to y plane, then you're gonna get this. Well, region D is a disk, so we can set this thing up. dA is dy, dx. So y is going to be between x going to be between. Right? Look at this one, x squared plus y squared equal 1. So there is just a circle radius 1. So I mean x is going to go between -1 and 1. Y going between the lower circle, the upper circle. So that would be a negative root of 1 minus x squared root of minus.
Oh yeah. Okay.
Minus root of 1 minus x squared root of 1 plus minus x squared. And then where does the z go from? Z is the height, right? So it goes from the bottom of the sphere to the top of the sphere. So that would be, well, if you solve for z, you see that z equal plus or minus square root of 4 minus x squared minus y. Actually, I'll do this thing and then it make it easier to convert into a cylindrical coordinate. Minus x squared plus y squared. Yeah. Okay, so minus root of 4 minus x squared plus y squared. Root of 4 minus x squared plus y squared. Yeah. So this is the setup in rectangular coordinate. It looks ugly though, very ugly, because whenever we see square root, we don't want to go through the integration. It's better to convert into well, that is the triple integral, right? Not double, so it's going to be a cylindrical coordinate. Okay, so into cylindrical coordinate, I mean, dA is gonna be all d theta. Yeah. The radius here gonna go from, and then the angle gonna go from. If you look at the region D here, it's the full circular disk, right? So 0 to 2 pi. Radius, well, circle only have a radius of 1, so it's gonna go from 0 to 1. Yeah. Look at this thing here, 0 to 2 pi, 0 to 1, and then we know x squared plus y squared is r squared, right? So it's going to be a minus root of 4 minus r squared, root of 4 minus r squared, and then it's going to be r dz dr d theta. Well, even with the square root, you can actually evaluate this thing. It's not that bad. Right? You have question, let me know. Because the lucky thing is that the integral is dependent on z, so it's just going to be a well, there's no z in here. See, so it's just going to be the top minus the bottom. And then you can just use the use up to get through the integration. Yeah. Okay. Look at this thing is it's z. It's z. Negative root 4 minus r square, root 4 minus r square, and then I'm gonna move the r to be out here. Dr d theta. I can just put the r next to dr d theta here. Integration is not that bad once you're in a cylindrical coordinate. So this just two copy of this. So 2 root of 4 minus r square r dr d theta, and then from here, what do we have? We have a 2r four minus r square dr, right? And then here comes just the u sub here. U is equal to well, I'm taking the whole thing here. 4 minus r square. So if we do that, there's going to be a negative 2, so it's going to have a negative 1. Two pi Okay, so -1 square root is 1/2, right? So 1/2 plus 1 is 3/2, 2/3, 4 minus r square, 3/2, right? 1 and 0. Okay. Sub it in. It's the -4 pi over 3. And what do we have in here? Let's see. You put in the number 1, so it's going to be 3/2. You put in the number 0. It's going to be -4 3/2. Well, you know, 4 3/2 is bigger. Oh, but then we can actually get 4 3/2 though. It's just 8. And then you just have to factor out the -1 and you just distribute in the -1 in. So it's going to be 4 pi over 3, 8 minus 3, 3/2. Okay, I want you to set up triple integral in cylindrical coordinate to evaluate the volume of a solid bounded and below by the xy plane the solid lie inside the cylinder. You can set this thing up real quick right here. This thing right here. Z is between 0 and root of x squared plus y squared, which is just r. So I mean, when you do the setup, the volume is gonna be, you can see the z right away. It's 1 dz 0 to r, and then here it's gonna be a r dr d theta. So it is inside the cylinder, meaning that well, dA is r dr d theta, and then the radius r is between 0 and 2. The angle is between 0 and 2 pi. Okay. Okay, so set up the integral to evaluate the volume of the solid enclosed by z equal x squared plus y squared z equal 1 and z equal 2, z square equal x square plus y square, z equal 1, z equal 2. Okay, so when I'm not by z equal 1 to z equal 2, so it's going to be a okay, so this is what it look like. If you set this thing up in cylindrical coordinate, it does get a little bit difficult though. So in order to do this thing here, you got to think up, if you have something like this, it would be best to sum up the slides. So look at the sample slides here, and then we're going to sum it up. See. We just have to sum up the sample slides and we're going to get the volume, right? Okay. So these sample slices that you are summing up from z equal 1 to z equal 2, 1 to 2. And now it's going to be dz. Okay, so sample size is going to be the area. If you look at one sample slice, right? The dA here is the RD theta. The angle theta, this is the entire distance. So it's got to be from 0 to 2 pi. But what about the radius r? The radius r is going to be from 0 to, look at the formula here. It's z squared equal x squared plus y squared. So the radius is z. Yeah, very good. So you go from 0 to z. This is the setup. It's tricky, but it does get the job done.